Hello, Jeremy. How are you doing today?
Good morning. Doing well.
Yep, excellent. Hello, Max. How are you doing?
Hi, very good. How are you?
Just another day in paradise.
Looking forward to our tutorial.
Born already.
So did you make changes to the first slides, just in case, because...
I don't think so.
Okay.
Give me my microphone. It's not just on. No, I don't think so. Oh, yeah, one slide. Wait, one change. Sorry. We present. I put you as MC up here. I moved it.
Yeah, that's more accurate because I will only be talking for the introduction.
Yeah, and then the QA.
Yeah.
When you go from part to part, we will say, you can point out that I will run that, and we have in each section we have the additional speakers.
I'm not sure what you mean.
For example, set speed were not done by Nishant and Mike. I will run it, but then we will have the additional speakers there.
Mm-hmm. You said you wanted to introduce the speakers for the second and third part, so I will introduce you on Reiner for the first part.
Yes.
Yeah.
No, I will do that with Jeremy as well then. Okay. All good. So I have Slack open, but it will be tricky. The disabled. Because it's able to chat in for Zoom. Okay. I see. We'll go to the slide one more time. Make sure that there's nothing funky. Jeremy, in this third section, do you want the slide that you're in control of the slides? Because it might be better because you have the long section there.
Sure. Yeah, I'll be ready for that.
So there's no changes to the. Do you have a share button? Just making sure that you log in.
Yes.
Okay. Then between the second and third, there will be a break, and then you will present there, and then at the end, I can present again. It's pretty much only the Q&A slides there. I can talk to them.
Okay. And I did get your latest copy.
Yeah, that should be number 9.
Yep.
Okay, that is. I have not made any changes after that. So at the end, I put the closing remarks. So you can display that, and then I will talk about the bounty program here, and then closing remarks, and then we can have a Q&A session. I don't need to switch over to presenter, but I can if you want. I have no preference.
Yep, I can do that.
It's just when there's a question, you need to go to the slides if you want to show the slides there somehow.
Sure.
Okay, cool.
Is it okay when I already mention the workload bounty program in 1 or 2 sentences in the beginning?
Oh, most definitely. And I can point out that I will explain that our intent there. What we do.
Yeah, just because it is part of our motivation why we're doing this tutorial in the first place.
Yeah, and that is how I will close. I try to close it in the closing remarks and at the end. Sounds good to me. And then Max, you will scan the Slack. And I have it open, but I cannot really concentrate on that as well.
Oh yeah, when I'm talking about the agenda, I will say that if people have questions, they should post those questions in the Slack channel, and we will then answer these questions in the end. So
yeah, at the end of each section.
Okay.
Not necessarily at the far end. Although if there's section for this section, there's questions, and we will answer them. And if they're appropriate or fitting in, I will address them right away. Chris says, good luck. Oh, no, Nishant is there. Hello, Nishant.
Hi, Klaus.
Max, from your experience yesterday, when should we start around 5 minutes after, so that people can actually start and they are saturated?
Yeah, sorry, at the moment, it seems like not even the presenters are complete. So we should definitely wait at least 1 or 2 minutes.
Yeah, maybe you can advertise a bit in the channel. We have in the other tutorials, we have some people dropped in, but it was also a bit of a problem at the beginning, I would say. But it tended to get better over time. But maybe some advertisement in the channel would be good. Yeah.
Hi, I'm Klaus. Who are you?
Sorry?
I'm Klaus. Who are you?
Hi, I'm Philip. Sorry, my name doesn't show up. Right.
Nope. It says conference 86.
So I just sent you an email a couple of minutes ago, I guess.
No, I have no email at this point.
Yeah, no problem.
Hey, Arthur, how are you doing today?
Hi, Klaus. Nice to see you here.
Excellent. Excellent.
I'm wondering why it's just 6 people in here. It should be more.
Yeah, it would be nice. I would agree with that.
For the first workshop, for storage performance, we got at least 15 people joining.
Yeah, it was earlier it was around 21 I counted. The good thing is the session will be recorded, and we will hopefully people then can look it up as well. They will not be part of the discussion, of course, but at least if a recorded version, we can see what we can do with that. Hello, Mike. How are you doing? Mr. Petrich? So, audio is not there yet. And Max, your camera could be a little bit lower. Right there. Excellent. Hi, Mike. Can you hear us now?
I can.
Excellent. You all good?
Yep.
Oh, you don't. Hey, Oni, how are you doing today?
Hey, Klaus, doing good. How are you? How's everyone? Hey,
Yeah, pretty good. Just getting all the folks together so that we can start. I would assume around in 3 minutes, 5 after, we will really start. People just coming in from the different events.
Great.
Thanks for joining. Hi, Marius. How you doing?
Hi, I'm fine. Thanks.
Excellent. Hello, David. How are you doing today?
Doing well. Morning, Klaus.
Good morning. We start around 2 minutes.
Okay.
People coming in. MX, do you think we should start?
Yes, I think we can start.
Okay, recording is in progress.
Yeah, tell me when you are ready.
Ready.
Okay, so hello everyone. I welcome you to our tutorial on the energy efficiency benchmark development. We are here today because energy efficiency is a crucial concern in the IT sector. And I dare to say that improving IT energy efficiency in general is one of the most important challenges of our time. Because of course, on the one hand, electricity can be very expensive in certain contexts. For instance, for data centers, the electricity usage costs can constitute a major fraction of the total operating costs of a data center. But more importantly, of course, most of the electricity is produced by means of fossil fuels, which is very harmful to the environment and consequently for everybody living on this planet. For quite some time now, SPEC power industry standard benchmarks have been a driving force behind measuring and improving the energy efficiency of IT systems, for instance, of servers. But of course, the IT industry is a very fast-paced industry. There are always novel developments, there are new usage contexts, there are new types of hardware being developed. And so in order to rate and improve the energy efficiency of novel types of hardware, or to improve and rate the energy efficiency of hardware in novel usage contexts, novel workloads for energy efficiency benchmarks are required. And so the goal of this tutorial is to introduce important foundations of energy efficiency benchmark development, which go far beyond the mere writing of code, for instance. We also want to provide a wider community of researchers with the motivation as well as the tools to develop novel workloads for their own energy efficiency experiments, but also for inclusion in energy efficiency benchmarks of the future. For this, for instance, we at SPEC are thinking about introducing a kind of workload bounty program where we might say, hey, for this certain context, we see the necessity for novel energy efficiency workloads. And then we invite researchers to develop novel workloads for this context. You might be rewarded for this, and your workloads might be included in future benchmarks, which are part of government regulations, so you can have a real impact on the future of the energy efficiency of the IT sector in this context. So the agenda for our tutorial today looks as follows. We basically have 3 parts of our tutorial. In the first part, we want to talk about important foundations of benchmark development, importance behind the scenes, and what are actually crucial steps to achieve a good benchmark. In the second part, we want to talk about the CERT suite. The server efficiency rating tool is a tool for evaluating the energy efficiency of servers and is, for instance, used in the context of the United States EPA's Energy Star program. In the third part, we want to talk about how to develop novel workloads by using the Chauffeur development kit. And I'm very happy that for this tutorial, we have leading experts of energy efficiency benchmark development as our presenters. For instance, we have Klaus-Dieter Lange, the SPEC International Standards Group Chair. We have David Reiner, the Green Grid Chair, as well as SPEC President. We have SPEC Server Efficiency Committee member Nishant and Mike. And I'm happy that Jeremy Arnold is with us today, the original developer of the Chauffeur development kit. At the end, we have a Q&A session. You can post, if you have questions, you can post those questions in the Slack channel, and we will answer these questions at the end of each part. And then, of course, we have the additional Q&A session in the end. Now for the first part of the tutorial, which will be presented to you by Klaus-Dieter Lange, I want to introduce to you Klaus. Klaus is founding chair of the SPEC Power Committee and also chair of the SPEC International Standards Group. Thank you, Klaus, for being here today, and the stage is yours.
Oh, thank you. Thank you very much, and welcome to the efficiency benchmark tutorial today. Before we talk about really the development piece, one of the things that we need to figure out always what is actually a good benchmark, because that's what the people involved in the development want to do. We here are all volunteers for SPEC in the SPEC committees. SPEC is a non-profit consortium, was established around 35 years ago. And in 2006, we decided that, performance workloads performance benchmarks are important, but the importance of the SPEC Power Committee about energy efficiency was around 2006. That was really the important part, and the committee members built this foundation what we live on. Let's go a little bit behind what has been done so far. In the SPEC Power Committee, we created the SPEC PTDman interface. back then we didn't have any really good way to measure power consumption in a way that is reproducible, that is really the quality there. All the different power analyzers, they had large differences how they reporting, in which formats they're reporting the data back and so on. What we created here in the SPEC Power Committee is this APA that where from a benchmark development, we're just saying, hey, give us the power data, give us the voltage, and it spits back. All the interaction between the power analyzer and the interface itself is already done, and we don't have to interfere with them. Over time, we have now over 30 power analyzers we're supporting, and it is a growing number. And new products come out of the market, we will add this. But in this tutorial today, we will not really talk about power itself. In ICP 2018, we gave a pretty comprehensive tutorial about power measurements, the interface, all the stuff that needs to be checked, verified behind the scenes in order to get the power measurement in. Although, if there's more interest in this, we can certainly talk in the end about that. But the tutorial we gave there in Berlin, I think is pretty comprehensive. And that is kind of one of the good things when you work in an industry standard environment, that what we're building up here, that we can reuse and enhance. What we did back then in 2006. Now, 16 years later, we can utilize it and work it. We don't have to reinvent the wheel. Of course, the Power Committee also created the benchmarks by SSJ, and Jeremy Arnold brought in the chauffeur framework that he developed in part with his master thesis. The chauffeur framework became now the standard set of what we're doing when we're doing energy efficiency development. It's a good framework, has a power interface included, has a lot of awesome features that hopefully we can see at the end of this tutorial. Also, what we learned, what we discovered doing our development, we wrote down in our benchmark methodology that you can access it publicly. So that when we're building a new benchmark, a new or adapting a workload with a new with a power measurement, description, what to do, what to look out for, what was pitfalls, it is described in the methodology, and it's used in order to maintain the brain trust of what we have learned. Then in 2016, we started the research group, the Power Research Group. And by now we publish over 20 publications. We got 2 awards, and we're publishing across different conferences like Mascot and of course ICPE. It's a great relationship because when we later going over development, we will see that there's a very nice tie-in between research and the industry to really get the best out of it. And then in 2020, we created the International Standards Group. In the past, when we wanted to adapt our benchmarks to the different global standards the governments have, we had to go and work individual with them. And we learned a lot of this, but it is an additional level, additional complexity. And we wanted to really, in order to really focus on the development of those standards, we wanted to have a group that really focused on that. At that point, we have 2 groups in there, the server efficiency group and the client efficiency group. They're focusing on this areas of expertise in order to push these standards and really ensure that they are working. That's kind of a rundown about standard performance evaluation corporation. Although in SPEC, we We are all volunteers. We have all the same level of access to code and so on. If you're in a large company or if you're an individual, your voice definitely counts there. The way we develop and stuff. Also, we developing by consensus. Also, the people, the volunteers coming in, they are making commitment that they want to develop something, and then every decision we make is a data-driven decision. Because it's really a designed by the committee. We're building consensus in order to, if there's disagreement, we're going by numbers, looking at research and doing our own research, of course. Also, we have to make sure that we ensure our quality requirements for benchmarks. So we will go over that in a moment. When we're developing in SPEC, we're developing it, we release it, and we maintain it, and we're retiring it. Each of the steps, I would say, somewhat equally important so that we have good quality benchmarks out. The thing is, since we're also doing the support, this is in our best interest to produce a quality product so that support questions are low, so that we can really focus on the development of it. Let's take a look a little bit on how we actually develop something. As in general, there's a concept or an idea brings in by one or multiples of the folks, of the volunteers, saying, hey, we want, for example, a client benchmark, a client efficiency benchmark. Then we're looking at, okay, what is the constant? We're looking at, okay, what research needs to be done? What is the items we knowing? What is the items we don't know? Again, the great thing is that we in SPEC can utilize what has been done before. We can utilize our code, the processes, as I mentioned, for example, the power framework, chauffeur, those items that is already proven on very high quality, we can use and see. Sometimes we have to adapt them, sometimes we have to enhance them with new items, but that is our research will show if you can match this standard. And of course, you have developed all the code development inside SPEC is inside SPEC, although it's by volunteers out there. And during this phase, we are also doing the workload creation. Although if you have a framework, we're creating the workload on top of it, hand in hand. Sometimes when we're creating the workload, we have to go back to research. That's a little bit iterative progress process, so that we're seeing how we developed it, and then saying if you're running into walls or something, we have to go research maybe a little more in order to create the workload at the end. The good thing again with the Power environment is that a lot of these items around what is not actually the workload is already there, and we can utilize processes in place and so on in order to do so. So really the focus is creating the workload. The next step when we actually finalize the development is the launch. The launch is a lot of times, you have a product, put it out there and people can utilize it. What we're doing is quite complex compared to that. We are going to a very large test metric so that we ensure that the quality requirements are met. We're going out to the people inside SPEC to re-verify that in their environment it works as well. Sometimes we have beta programs, especially when we have interaction with it, if it's for a specific government, that they have we creating big beta programs for them in order to make that work. And also, when we're launching something, the education of the folks who are using it is there, make sure that they can utilize our product by just using the documentation, so that it is really on that quality level. And of course, to the launch is also the interaction with the government agencies to really adopt it in their government regulations. So once it's launched, we also retain this product. we have to say that it is maintains valid. Or when we're developing something, we cannot develop it for today. We have to develop for the future multiple years in advance, saying, okay, what is coming out in the next 3, 4, 5, 6, 7 years, in order to see, can the workload actually is that still meaningless for the end customer? And that is we are pretty successful with that because we have the developers, the volunteers come from the different companies, stakeholders in the industry, and bringing stuff in, and we are in order to ensure we're good. But then we also have to see that eventually we have to retire a version or the complete new create maybe a complete new benchmark. And we at this point we are with the third suite, and this is currently in a very good shape. It will maintain for a while, but we have at this point we have to look at, okay, we have to update it, make it more valuable for the next generation of workloads. And that is actually the point we're here, and that is the opportunity the researchers have now. Okay, on the workload creation, everything around it is pretty much there, and we really need to focus on creating the workloads. I hope that gives you a little bit idea behind the scenes how SPEC works. Of course, it is all a little bit fast-paced put on, but that is really the meat of it. At this point, I should point out, we have created this book with a lot of the folks from the people in the community. Around 45 different folks from industry and research have worked on this in order to really get more in detail about all of these items. One of you will actually exactly get this copy at the end of the talk. You will have we will select one of the audience members, most likely the one with the best questions, in order to celebrate that your interaction with us. Also, this will be your copy. One of you will receive that as after the meeting. We will put down your name and then we send it to you. Okie dokie. This is about the collaboration here. So now let's talk about benchmark quality. In general, there is these 5 ones: relevance, reproducible, fairness, verifiable, and economical. So relevance, of course, what we measure, that needs the metric that's coming out at the end, that needs to be something that is of use for the end customer. If it's for a government agency, if it's for somebody who buys a product, it has to be relevant. It has to be reproducible. Also, if I run it, or somebody who is not so familiar with that, or if I rerun it over and over again, I should get the same result out, if for the same test configuration. It should be fair. And fairness is one of the things that SPEC really accelerate, because we have all the competitors inside SPEC and also the partners. There is a good watchdog around it, because when we're making code changes, when we're making additions, when we select the workloads, it is not 1 or 2 big companies. There's a series of different competitors and then researchers in order to come up with the final product. Also, you have the fairness already built in. Of course, you have to at the end doing some verification of that, and then we later on we will have showing you some of our work we're doing in order to how we ensure fairness in the development process. Of course, you need to be the results need to be verifiable in order to ensure that the benchmarks can be seen as accurate. For a lot of times for the government agency, we have log files that is encoded so that you cannot accidentally make changes in there, and really see that at the end you have something that is reproducible and then verifiable. If you rerun, you have really metrics, and you can really say this is a metric from a SPEC benchmark that come out, and that you trust that. And then economical, or the ease of use. We have to ensure that when people run it, it has to be somewhat not bank breaking when you want to create something. Also you can, like for example, a good example is the thermal chamber. So when we looked at this, you need to have some kind of a balance. How much money can you actually spend into the effort to creating a result? And in the beginning, we said, oh, we needed thermal chamber in order to measure actually results. At the end, we came up that a temperature sensor that is in the inlet of the air intake that is sufficient enough, and that has the right balance. You paying, instead of paying 50 grand for thermal chamber, you're paying maybe $50 for a temperature sensor. And that's it has to be economic. Is it the best solution from a technical standpoint? Probably not, but from an economical standpoint and really how much more it gives you, yes, this is definitely the right decision to do so. And when we're developing something, we have to ensure that we will get these quality requirements in place. So from a benchmark perspective, a lot of times when I have discussion and benchmarks, people think that is just a workload and it's something I run on that. But it's by far more, at least for us. The workload, we have the hardware and software manufacturer, you work mass together. We have the researchers working together to get the workload. But then the workload has to work and has to be utilized through a framework where where everything is coordinated, and the power analyzer produces the results, and we pulling them in. That goes at the same time and get commingled in one data set at the end with the reporting mechanism we have, or that is in part-time. Reporting is also important not only for the results, but also for the remaining of your test environment, because we have to report it. What you actually measured is not only the number, it's also what you measure. Again, part of our components is the power methodology, the benchmark methodology we created where we learn it. We also put a design document and the user guide out so that people can utilize what we have done and make it easy for the user to run it just by development. For the workload itself, of course, we need a metric, and then as an output is part of it, and that's again the fairness component. And in order to everything works, we have run and reporting it, how you utilize it, how you run it, and how you actually can utilize the report in a fair manner. For the run and reporting rules, we have to really put a good balance in it, that we don't put too many restrictions on it or too few, because we have to ensure that the condition we measured are fair across the different platforms that's out there, and different architectures that's out there. We cannot just exclude something because we want to exclude something. Also the reporting, we have to ensure that that somebody just with the report itself is able to reproduce the result so that it can be verified if it's there. And let me give me a little bit examples here so that people get an idea. Also, in general, you have, when we have a benchmark, you can run it on a various of hardware and software components. Sometimes you have to restrict it in order to, sometimes there's a minimum requirement. For example, when you use Java, is your workload in Java, you need support for Java, the OS, and the hardware that for this environment to work. And then we don't put the restriction on. The restriction comes then from what the Java environment, the Jvm actually needs for hardware. If you have a workload that has heavy disk I/O, we need, in order to achieve a certain level of storage I/O. There's now, of course, there's a limit or a minimum requirement that we need this hard drive in order to run it. Portability is a big item in order to be fair. And you want that that the code that is actually executed does the same thing. When you have something in Java, it is relatively simple. And because we writing it in Java and then the JVM itself has portability there. A little more difficult when you have C, C++, or any other native language that needs to be compiled. Then you need to have rules around how to fairly compile it so that you have no unfair advantage or disadvantage. And minimum airline temperature, that's one of the rules we had to create, saying we didn't want it that in order to be fair, we wanted to have it in an environment that you run it. And therefore we set a minimum air inlet temperature. Does that make sense? By the way, I'm talking, but if there's questions, you can do the Slack, and if there's, and we will, after each session, we will have a Q&A and then the break. So now for the, when we're going on the third speed, it's first time we created a benchmark, an industry standard benchmark that is really focusing on government agencies and their program. That is built for this kind of programs. A normally benchmark in our world, we're using a lot for competing company A with company B. Here, we wanted to have a rating tool that is not used for this kind of work. Wait a second. Give me a second. I do not know what. That's my people. That's really the tool we created in order to have something that it can set a threshold on saying, hey, for this government agency, this is the runs we need to do in order to get good results, and that is how they can compete. It runs different worklets. It's focused on storage, memory, and CPU. And it can also run on multiple load levels. That is something we developed in order to really emphasize on stressing the power management in the server. And this is now used in different energy programs worldwide. The goal was to get it global harmonized, although having one international standard benchmark used in every region and national standards for regulations of system energy efficiency. When we released Third 2 in 2017, the US EPA adopted it right off the get-go and using it for the Energy Star version 2 program. Much before that, since 2006, we're actually working with Energy Star and the different government agencies to have this interaction. But for the Third 2, there's where we get the metric and done, and we got then the thresholds in the EPA. Of course, we developing further with version 2.2. Japan and the European Union adopted it in their programs. We created 2 or 3 improvements with feedback from our customers. And then in late 2019, actually, our cert was adopted in the ISO standard so that it's easier to adopt it worldwide. The ISO standard is adopted from many countries. If it's in the European Union, if it's in Asia, if it's here in the US, that's adopted in the ISO, and CERT is the tool that is described there and PTDman in order to get these measurements done. Was a major step for us to do that. It was a lot of effort from a lot of folks inside SPEC, the volunteers there, and we came out with a nice described ISO process. So now with 204, since we're following ISO in this part, 204 was right away ISO compliant as well, and we are soon to be releasing 205, and will be also ISO compliant. So the idea that we have one standard is really that to lower the cost of measurements in the different regions. If you need to, if every region has its own standard, then yeah, each company has to measure to the standard over and over again for each of the models they want to sell. That is quite expensive, and we rather focus getting these expense in making the machines more energy efficient. Because if there's one standard agreed from the industry, then design of servers or IT equipment can focus on the standard on saying this is now how we should build it in order to make it more energy efficiency. And it drives innovation. You really want that the different companies investing in that are not in different measurements for different regulations. And this also makes us measurements more comparable across the region. If you have this data set that works in the US and in Europe, in Asia, then researchers can use all of the data because it's done with the same tool set and utilize the data, analyze them, and come up with new ideas or with problems that we're seeing in OSs or in hardware development or something like this, and then pinpoint them out. This work is a pretty huge list, and we have to do work together with the US, EPA, with EU, in China with CNES, Japan and with JADA. And one of the organizations we're working with quite close is the Green Grid. And at this point, I would like to introduce you to David Reiner. He is the Green Grid chair and the SPEC president. And he drives a lot of these interaction with the governments, also with ISO, in order that our products get adopted. David, at this point, I give you the floor.
Okay, thanks a lot, Klaus. It's good to be here. Yes, so the Green Grid, it's an organization, a nonprofit organization similar to SPEC. It was founded in 2007. And we have quite a few industry companies that come together to make, there's kind of two halves of Green Grid. One half that works on technical standards. So for instance, as I noted there, the PUE standard that's become very important in data centers was created by Green Grid a number of years ago, and there's a number of other standards as well. And then there's also an advocacy half of our organization that works with governments on energy efficiency programs and regulations. So the charter and focus of Green Grid is enabling data center efficiency. And one of our most important partners is SPEC, and the committee that Klaus, or the ISG committee on the SPEC power side and on the ISG side, both are people we work with. So I want to talk a little bit about some of the specific things in a minute that we've worked on. Another project though that the Green Grid has is working on is with the Energy Star program with the EPA for data centers. So this is separate from the server program, and this basically helps create a score for data centers that you can look up online that helps measure their energy efficiency. So over a decade ago, there was the first generation of this metric that was mostly just PUE, and now we are partnering with the EPA to update that, add more new measures, make it more modern, and so that's something, yes, that's happening within the Green Grid. Yeah, so I think that's what I have here. Klaus, did you have anything else on the
Yeah,
green
no,
grid?
thank you for having me. No, it is always a pleasure working with you on your team on the green grid side, because what we're doing here in SPEC and developing it, and then we have a good tool. You might may I ask you, can you describe a little bit when we're working really on setting the threshold, the work behind that, the data you need to gather in order to interact with, for example, the lot 9 and can you maybe give us some insight what you had to do there in order to make that actually happen?
Yeah, good question. So there's a lot more. We're talking about the benchmark mostly during this presentation, but there's a lot more to a government regulation coming into effect, and there's a lot of details that are created in that regulation. And typically, the policy officer is not a deep technical expert, and so there's an important work between industry that has a lot of the technical experts and the policy expert or policy officers for the different governments to get all those details right and make sure it's actually surprisingly easy for a regulation to be written in a way that actually can de-incentivize energy efficiency savings as opposed to incentivize them. So one of the pieces is as Klaus mentioned, is thresholding. So in the regulations, governments typically have a certain target percentage that they are aiming to. For instance, in the Energy Star program, they're trying to label and incentivize the top 25% typically of servers to the 25% most energy efficient. Those are the ones they're looking at making an Energy Star or giving the Energy Star label. Whereas in the EU, for example, where it's a market entry requirement, they typically look at the bottom 10 to 15% that they want to exclude from the market of the least energy efficient servers. So one of the partnerships that Green Grid and SPEC have is that Green Grid maintains a database of SPEC Cert Suite results. I have on the order of 1,000 results, and this is the way that when you look at those targets, you look at the last few years of server results, and then you can look and say, okay, well, this is the cert score that is required to get a 15% fail rate or a 25% pass rate on it. So that's one example, and some of that data was shared from SPEC and from other sources. The other piece is the next version of SPEC Cert. So there's been discussion on what we want to do to improve CERT since it came out, and this piece, the Green Grid has been partnering with SPEC to go talk to the governments, talk to other stakeholders around the world, pull all that information together of what they think is the best improvements, what are the things that have changed since CERT 2 came out, and so that's another partnership opportunity.
Yeah, thanks, David. Thanks, David, for taking out of so much time out of your very busy schedule. Appreciate it.
Absolutely, it's good to be here.
Yes, but looking at the next generation of workloads. So when we're looking at SSJ, there was some Java transactions. We had insert. We have 11 workloads there and complex. But now we're looking at what we really want for the next version, because in several years there's probably an update needed, and we're working on this. And that is what we're looking right now on when we're looking at next generation efficiency workloads. That's the workloads on the technologies we want to target. Currently, that is our list we came up with. And then the Green Grid is now sharing that with different adding that with their own ideas, and then having the discussion on what we really need there, what is upcoming technology that is really important, that we will be capturing the energy efficiency there. And that is why we have, for example, this tutorial today, that we need these workloads, and we will have specific requirements on those. And one of them being has to be written so that we can utilize it in Chauffeur, and then we would like to include them in our next benchmark, of course. The cool thing is, again, as a programmer, as somebody who wants to develop it, you really need to look only at the workload itself. You don't need to look about the reporting, about the fairness, about the portability and so on, because that's around on the chauffeur framework. That's what we largely already solved. Of course, we have to making sure that still makes these criteria. But this is really the opportunity for somebody who wants to be in this world, wants to ensure that the next generation of benchmarks is there and we saving energy. That is a great way to just plug in the workload of what you want to create and don't have to think about all the workload benchmark specifics around it. Okie dokie. That should have given you a kind of an idea what we're thinking about, what is a good benchmark, what we want, and how we're moving forward. At this point, do we want a short break, or people feel comfortable that we can move forward with? So then we might have a longer break. Are there any questions from the audience? Marius, any questions? Uber?
Well, you showed us some quality requirements for benchmarks.
Yeah.
And I asked myself, how do you assess things like the economical efficiency or the fairness? Do you simply compare two benchmarks, or are there like numbers?
Yeah, economical. One of my points is it has to be because this is run not necessarily by people who are doing benchmarks on a regular basis. They're run by test labs a lot of times, and we will show you what we have done for CERT. But here we really have to see when we're creating it, what are the requirements? For example, we joking around and I a lot of times say, hey, my manager needs to be able to run it. Cannot be complicated. My manager needs to be run it. Unfortunately, my management is not technical savvy and that doesn't work anymore. But you have to see how much expertise you need to run it to get a quality result of it. And if you're making steps that, for example, it's too complex or requires a lot of in-depth knowledge of the server, then it's definitely not a good way to be economical. For the fairness, the process itself we have in place is already a lot of fair. And we will, in the second sections, we will actually have some examples for CERT where we will go into what we saw as a result, and then seeing what fairness we can do around that. Okay, does that answer your question for now? And we will go a little more in detail in the second session.
Yeah, thanks.
Nuba, anything on your side? Jan? Okay. Okay, Arthur, any question on your side? No. Sang Hao? Okay. Max, do you want me to move ahead or?
The second part is only half an hour. Am I right?
No, 45.
Okay.
Yeah.
From my point of view, we could just move on.
Okay.
And then have a break between parts 2 and 3.
Yeah, I think that is good. Thank you. Okay. Efficiency benchmark development. In this part, we want to really show you how we, some of the aspects when we created CERT Suite. Also, like Mario said, there's quality requirements, how we actually measure that at the end, how we compare about what we're doing in development, and how is that actually in real life. Because that is part of, before we launching a product, we have to make sure that we're making those. And for this, we have we will have a little demo about the GUI that shows you the how easy it is to run it actually. We have Mike Petrich from and Nishant Rawtani. Both are SPEC Power committee members and also in part of the efficiency group in ISG. They're long-time users of it and part of the development team or extended development team, and they will give you a nice rundown about the GUI in this section. Okay, let's go ahead and see what we actually have done. So the third architecture, when you see, we have the set, that is the user, sorry, it's the system on a test, and that is actually the one we want to measure. For that, we have a power analyzer external to the device, and that's connected to the interface. It can be in GBIF, USB, or something, or then to PTDmin. And the PTDmin is reporting to the controller system, the chauffeur, director, GUI. That's all on the controller side. That is a separate unit. A lot of times this can be a laptop, and that controls the system, therefore controller. It controls the start and end of the benchmark, the reporting of the temperature and the power will be captured in specific intervals, and they're connected with the NIC so that they can run with that. It's the good thing about this, or many good things, but one of the great things if you actually do a lot of measurements, you have the controller system, power analyzer, temperatures are set up, and you can exchange your SAT or make changes to your SAT, improve it, and but your controller system is a stable part of that. Again, power analyzers, since we have the PTDmin-based interface, you can easily put a different power analyzer from the acceptance list on it, depending on which region you are. The accessibility to one power analyzer to the other might be not there, but since we have developers around the world, we have a power analyzer that's available in Asia, in Europe, and in US, of course. Those measurements, in order again to get it economic to run. You cannot buy a power analyzer for 10 grand and ship it over for another 5 grand or something. That is not economical. You have to see if a local person can actually run it in an environment that it works. And those items, Marcus' questions was how we measure economic. Also in each aspect of what we're doing, what kind of power analyzers we are allowing, including those items need to be looked at, like temperature and sensors. One of them got retired, and we have now to make sure that we have ways, or we have new temperature sensors that people can buy in each of the regions, and in order to make it fair. You cannot have a restriction that somebody can and other people cannot have access to something. That is each aspect we have to look at these quality items in there. So, and then of course, with the GUI, we will kick off the run. It runs and then it reports back and monitors during the run files the items. So that's an architecture we have, and we will maintain. That seems to be pretty proven over 16 years, and of course this will be updated and improved, but that's in general the architecture itself. One of the things what we did in SPEC Power SSJ and now also in CERT is that we created the concept of load level. We're not stressing the system only at 100%. We can stress the system on different scenarios. We have the different workload levels, the different workloads inside CERT, not only runs at 100, runs at different load levels, and depending on what kind of workloads they are, they're not all running on the same load levels. They have different ones. It's a balance between, again, how to make it economical. The balance between what is the information we need out of the measurements, and then on the other hand, what is the time, how long it runs. yes, you can make it in 1% steps, and it takes probably around 2 days to run. In this case, we have we set a target for us that in order to have make it useful, we need around a run should be around 2 hours. You get around 5 runs in per day, and that's just a good set of measurements in order to get your experiment going. Again, this is all design sessions you do during the run, during the development time, and then look at how much makes a sense to do that. We have for the different load levels, one misconception is a lot of times, hey, that the CPU utilization. It is not. It is really performance. Also, whenever we run it, there's calibration phase in the beginning here, where we run the workload in transactions, but unlimited. Also, we just run it until we cannot do anymore. And we do several of the calibration, and we using the average of the last 2 of those in order to determine what is our 100% level. And then we then actually in the measurement phase, we issuing this 100%, and then we going down and using other load levels depending on what we think it's important for this particular workload to be giving us meaningful results. Again, as a developer for the chauffeur harness, you not necessarily, or you actually don't have to think about that too much, because you're creating your transactions, and all this other stuff with the load levels, with the reporting and so on, is part of the framework harness. Although you only have to develop really for your workload itself and can focus on this, what's important to you. Yeah, that's on the load levels. Now for the metric, when we're looking at, okay, what is the fair metric? We have when I go from the opposite, and hopefully bear with me because it's a larger process. We looked at what we want to do, and we created the third metric in 3 sections. We have the efficiency of the CPU, we have the efficiency of memory, and we have the efficiency of the storage. And that's we're combining them with weight, 65%, 30%, and 5%. And that combines the metric itself. Maybe since David talked about it earlier, so coming up with these weights at the end, we did, of course, our measurements, but we also seek input from other entities, for example, the Green Grid, in order to really come up with what is fair, what is fair across the industry, not for only people who are in SPEC, but also for people who are in Green Grid on the interaction with the different items. Those things are very impactful, and we need to ensure that they are fair across the industry. Therefore, specifically when we talk about the weights, we had a huge discussion, actually a series of large experiments in order to go and ensure that, yeah, that is the right mix of them. So the efficiency scores, memory efficiency scores, and storage efficiency scores are created by using the power and performance of each of the workloads. So each workload, compress, crypto, LU, and so on. The memory ones, flood, capacity, they are getting combined in the workload efficiency score. So we have a score for storage, memory, and CPU, and from each of the target load levels that we're actually utilizing, because each of the workloads is executed. Here you see the 3 calibration runs, 100%, and then a fraction of the 100%. And as I mentioned, some of them have multiple load levels, like this one has 150, and this one has more in steps of 12, this one on steps of 33%. Again, make it fair, make it go economical, because you wanted a runtime from around 2 hours. And do we get really the information at the end we need in order to, or the end customer of the results wants to see, if it's a government agency, if it's for, if it's really stresses the system. You also have to think about, or we have to think about, we want to encourage behavior so that that people building more energy efficient systems, if it's software, if it's hardware. And in the beginning, this target load levels, for example, not all of the CPUs had really ways to shut down things in order to save energy if they're not used very well. But over the time, since 2006, there's huge improvements in there. And we have the improvements because we were able to really, there's a way to measure it in order to showcase it. Hey, my system is better because we can save energy if we don't utilize it. But we have to really think about, when we development workloads, about future, how we can encourage, what would be a good behavior from a system that in order to make it more energy efficient. So it's a complex task, but that's what we do. So that gives you an idea, hopefully, about what the metric comes up. Now I would like to introduce you to Nishant and Mike. Again, both a long-time member of the SPEC Power Committee on ISG, and they will provide you an idea about how it is to run the cert. Go ahead.
Thank you, Klaus. Nishant and I will take you through some of the CERT user interface panels here briefly. So the first GUI panel you see, lists the sequence of steps in the left pane. And then on the right, we see the CERT setup architecture, wherein the CERT workload resides and are executed on the SUT, while the controller machine handles the CERT chauffeur, director, reporter, and the GUI. CERT UI can control one or more SUT. The SUT config page allows us to enter the IP of a single or multiple SUT. Additionally, before proceeding further, CERT can verify that all the SUT are up and the necessary CERT services have been started on the SUT. CERT also automatically collects hardware and software discovery information on all the SUT, which will be used in the next step. The hardware and software discovery data, which is collected in the previous step, can be verified by the user. The SUT configuration is separated into different sections, such as basic SUT info, CPU info, etc. The data populated in these sections will be used in the test report that's generated when the test completes. Some of this info collected during the discovery is auto-populated, but some are not. For example, the test environment section, that is all a very location-specific, company-specific information that's going to be manually populated by the test organization or individual. An underscore in any field basically shows that a default value is in place and needs to be changed. A separate example would be like the memory details fields, where stuff that's machine readable will be automatically populated. But in the end, all fields are editable and the end user is responsible for correctness. PTDaemon is an ISO certified method for collecting power and temperature data. It provides access to different port interface and device types for measuring power and temperature. Once the information is entered, this data remains stored, and PTDaemon also assist novice users with range settings, which is described in greater detail in the user guide. With that, I'll hand it over to Nishant.
Thanks, Mike. So moving on to the JVM configuration, this page basically has a list of all the JVM tunings which are preset by the platform owners. So what this does is basically it abstracts from a user the hardware and the tunings which are specific to the hardware and the software stack. How does this help is in two ways. The first one being that it helps keeping a level playing field between different hardware vendors because they have to use the same tunings on a similar configuration hardware. And secondly, it also, because it abstracts all these nitty-gritty details of the software and the hardware stack, it allows any experienced user or a novice user to be able to replicate the same runs on a given hardware. So moving on to the JVM review, all the particular JVMs which were selected on the previous stage by the which were preset by the platform owners are listed here. This can be used by any interested user to see what are the tunings which are going for different workloads of CERT. Now, while CERT is built to be repeatable and to be compliant in reporting the results, it still has the flexibility to be able to run different workloads. How this helps is basically it helps industry practitioners to be able to root cause issues by running specific workloads. Like a person wants to identify issue in a memory-based workload, he can run only memory-specific workloads. Similarly, if any researcher is trying to stress a particular component of a system, they could also choose a particular workload which helps their particular research. And also during this stage, CERT does perform certain checks. So one of them being, as you can see, it's a storage path verification. So it verifies if the path actually exists on this storage volume of the system. And secondly, because of CERT's requirements, it requires that the write cache is disabled. And that is also a verification which is done by CERT before the runs are started. Now moving on, since we saw that a lot of pre-checks have been done by this stage, we are ready to launch the workload. And this, because we are, after a lot of pre-checks have gone in, you're very likely to get a compliant and repeatable result at this stage. Also, this dashboard particularly gives you information to the workload which is being run. So CERT overall runs for 2 hours and 10 minutes, but this particular dashboard has a reverse timer to see where in the particular run, which phase of the particular run you are in currently. Now, once the results have been generated when the workload has completed, this page basically lists out all the runs which have been performed by CERT till now. Also, we have some annotation features, particularly the name and the description field, so that it can give a user a user can basically enter more details of the particular run which have been done. And finally, moving on to the help page. Although the latest documents of the help of the CERT are available on the website, however, by shipping help pages with the CERT media itself, it provides ease for a user to have a quick glance of the required documentations. And also, if CERT is being deployed in dead networks where there's no internet access, a user would have access to the help documents in such a scenario also. So to conclude at this point, we have seen that how easy it is to run CERT for any user, be him experienced or a beginner, to be able to produce reproducible runs which are compliant and also which can be reported. Over to you, Klaus.
Yeah, thank you very much. Yeah, now you have seen how, when we talk about economically, this is step by step. You click it, and we put a lot of effort in it that the end user can nicely go through the steps guided by the GUI in order to get something that is of quality, that can be used for your government regulations. Is there any, before we moving on, is there any question about the GUI? Marius, is that is this one another example where we're looking at, okay, we want to make it easy for the person, we want to not that you spend so much time on setup and all this, that you can run it the way it is and you're getting good results. Does that make sense?
Yeah, it makes sense. And I also see your point now. I guess everyone is able to run this test.
Yes, that's the point. And now think about it as a developer. I do not know if you are, but as a developer, I don't have to create now the GUI for the new benchmark. I don't have to do this and this. This has been done, and we will of course improve it. But what we're focusing here in the third part is how now can I create for whatever research I do, what you want, my own workload, and I put it into this framework. I don't have to think about the results, output, and. Although that makes it very economical from our perspective. So now we saw how to run it. We saw the metric is. Now I want to give you a couple examples of our research we did on the results itself, because that is very important for us. Before we really release anything, we have to make sure that it really works. And again, the fantastic thing in SPEC is that you have the different companies, stakeholders from software and hardware in here, and we have access to the latest machines, a lot of times to upcoming machines, platforms that's not available yet, in order to do analysis. I'm not really pointing out, okay, this is what we want to do. And when you look at our metric paper, and these next slides are from there, we looking, for example, okay, how is now our workload behaves with different memory channels? And we're seeing clearly that, it seems to be a maximum of 8. Anything below that, you will get a decrease in performance. And actually a decrease in energy efficiency. So the normalized search score is as an energy efficiency number. But then we also, that is just with one dimension. The other dimension we put in here. So how does that behave with core count? Does it change? Or does it stay the same? And then you clearly see that core count, more cores, that gives you more performance, but also costs you more energy. And then overall, you're getting results on that are meaningful. Those experiments, this is one of many experiments we have doing. We're not only doing at the end, but doing the development itself. When we have code changes, when we have a workload that we like, and I mean, we going in different dimensions, saying, okay, we like it, sounds good that it works, looks good on paper, but we're looking at the overall machine. One thing, I hope that is clear, that we are not looking at internal counters for power or the temperature or any of those values. We're looking at what the customer at the end sees. We're measuring the AC input of the server. Therefore, yes, we're saying we change this in the system. For example, in this case, the CPU for the different core counts, or that the memory be properly different. But now this has a lot of impact on the system itself, on the power management, on the fan behavior, and so on. And therefore, we can theorize what should happen, but then also you have to see how the system is set up, or which power management is enabled, or what features this particular platform has for power management, and then we're seeing behavior. And then we have to, every of the companies will analyze, of course, the workload, and then we have to see, okay, is that fair? Does someone get an unfair advantage or a fair advantage because of the architecture? And those are details we're discussing, and therefore Internally, this is confidential, how we're doing things. There's the details behind it inside SPEC. Also, we have an open conversation there. And then the output, our conclusion, we're making it public in the benchmark in order to, hey, this is what we agreed on. This is the industry standard we want to move forward for. So this is one of many examples. Another example is here. We looked at the power consumption and the energy efficiency of crypto AIS as one of our worklets, and we look at with different kind of processes, and we look at different target load levels. So, and that's why a lot of target load levels and different workloads are important, because they're behaving differently. You see that, in this case, memory channels make a big impact, and that you have different expectations. A lot of times people saying, okay, if I get a big processor in, I use a lot of power consumption. But does not necessarily mean that is also the most, that is not as good as in energy efficiency than other ones. You see that different processors here behave differently. They have different characteristics and the different channels as well. Also, when we have a large difference between idle and max load, that is not necessarily a sign of high energy efficiency. Therefore, we measuring it, doing our runs and at different target load levels and seeing what is important, again, for the end customer who runs it, how they're running it, and how we will be able to capture those. This is on the hardware side, but also we have it on the software side. In this case, we have the same setup, but measured with two different OSs. First of all, also, if you don't know, the compressed crypto, that's a different CPU worklets insert, and you're already seeing that it behaves actually different. And they are not all the same. They are implemented differently. They're doing different things in the CPU, in the system, and therefore it's stressing this system quite a bit. And when you look at power consumption, we have 3.5 to, you have around 25% difference, just how you stress it at 100%. Therefore, we have different workloads to show different aspects of the system and how it works. But then you also see that it is not that one OS is necessarily better than the other one. They all behave fundamentally different. You see that here the one workload is on the bottom, the other one is more in the middle range. There's definitely tendencies there. There's the same, but they behaving differently and different target load levels. Yeah, at the end, they might be good in the beginning, idle, they're somewhat on the same, but the behavior in between, where power management comes in and can make a difference if you don't stress your system 100% all the time. And yeah, those aspects we have to see, we have to make it fair. Is there a rule we should put around that? Is that this or is this not allowed? This is all the discussion we have in order to make it fair. Therefore, rebuilding consensus, making sure that if people have a direction we want to go, that it is a data-driven process, and we can do that. And that is why it's so important that we have a lot of different workloads available, that we can see how they impact, how they differently stress the system, and how they impact the energy efficiency at the end. Okay. One more thing. That was from the OS, that is from the JVM, for example, in this case. Again, the implementation of a JVM might be different, and then it behaves, of course, differently. That is something external, because you can choose which JVM you're using. At least that is our rule says. We want to give people the freedom that they can do. But then we also have to see that it shows difference. If one JVM has implementation for utilizing accelerator cards, yes, of course, they will get a benefit, but that is also a benefit the customer at the end will see if they have, if they're using the JVM and they accessing their accelerator card for some of the part. That's a real benefit. Yeah, it's a difference, but it's a real benefit. And we don't want, we want support anything that is get more energy efficient. Or we don't want to restrict it. Although the balance is quite complex. I hope that gives a little bit insight. I mean, this you can find more in detail in our metric paper in order to get more in the details if you want to be interested in our research. But that is very few examples. So, for example, I'll show you here from stuff we have to go through in order to ensure that and ensure these quality items. As Marcus here, this is kind of a checklist for us to seeing previous third relevance. Also, does it measure actually the energy across a wider spectrum of server configuration? Although that you can use different equipment piece, different configuration. And really, if you get a system that is more energy efficient, that actually at the end comes out this way. Also, relevance, how we stay relevant, how it can be updated. Also in this case, it is not how we created the workload, it is how we maintaining it. And that's when we saying relevance, yes, we are definitely there. Reproducibility, can you reproduce it? During our launch, we measuring it on different platforms and over again. We're making sure that our hardware detection is there, software detection is there as well, in order to have a full disclosure report that really describes in order to reproduce it. Fairness, it has to be portable. Also, if you see, we have individuals today here, yeah, they're all working as volunteers in SPEC, but you have volunteers from AMD and Intel, we have from Microsoft, we have from HPE and IBM, for example, today on the call, and we put that together. And we have to make sure that all those things, all the platforms these vendors have and can support, are being supported. And that's where the fairness comes in. And therefore, we're developing it in the industry consortium, because we have to make sure that the different OSs and platforms are supported. So there's where the fairness comes in. And yeah, building consensus is by any means not easy, especially when you have different architectures. But we're coming up with a solution instead of overruling some or not. We're coming up with a solution at the end where we all agree and saying, okay, that is what is fair. Verifiability, I mentioned hardware detection, and that we have all those stuff that people cannot necessarily tamper with our results if somebody really wants to. It's very important for government agencies so that they can trust the results and later on can do that. These government regulation a lot of times prevent people to sell, for example, in the European market. If you do not run CERT on your platform, one can prove that it makes a threshold. You cannot sell into the European market. And that is, of course, a lot of money involved. And in order to prevent behavior that we don't want, of course, we're putting items in order not that the results cannot be tampered with. And then economically, also when you saw GUI to run it, it's easy to set it up. You need some knowledge, of course. Easy is relative. Also, if you have a complex workload, yeah, you have to be somehow involved in what it does. You have to know how to set up a server in order to run it, yes. But you don't have to performance expert with 20 years of experience in order to get a good results out of it. Also, quite frankly, if you run, since all the tuning is done, if I run it, I'm part of the development, or if if my manager runs it, or my little sister and my sister run it, actually doing the testing, we're all getting the same results on, because this is really for the efficiency reading tool. It is not a benchmark where the tuning is free, it is limited. for the platforms, as Nishant showed earlier. And here it's important that you all get the same results at the end, even if you have more knowledge or more experience within this field, because this is really created for this kind of scenario. And yes, then we have the economically piece in there. I hope you, Marcus, you agree. That's kind of pieces we're going through in order to ensure these items. And that is not one person or one company or a small set of companies. That's where the industry comes together, and sometimes in SPEC together, and sometimes we reaching out also to the Green Grid or other consortia and the government agency directly in order to ensure, okay, this is what it does. Here you have another data program in order to verify if it really meets your standard. Okie dokie. So now there is a demand for novel worklets. We are in a point right now where we're looking at SPEC Power Next as the next generation of a benchmark that's really for marketing comparison and so on. We're looking for looking forward to CERT in order to looking what we need for the next generation of benchmark with kind of workload. Again, we are collaborating with the Green Grid there in order to getting their input from their membership, but also the interaction with the different government agencies and seeing what they're thinking, what is important for them, so that we have at the end a comprehensive item. The thing what we want to do out of this, that if you're interested in being part of it, then you can. We in the next section, Jeremy Arnold will show you how to develop actually a new workload or bring in a workload into the chauffeur harness so that we can actually utilize it and run it. We're building right now the bounty program for you, where we will have specifics. Okay, we want a workload around this topic, and then with some requirements. And then we will send out a bounty that you will be mentioned as co-developer. You will be mentioned as, well, you will get credited for your work in the credit page, of course, and in our documentation. And we will be looking right now for a monetary award as well, so that your work has been done. Your work, you will be able to keep your work, but we will have you have to give it to SPEC so that we can use it in our benchmark. We're trying to make it less paperwork and really to the point. Although the turnaround time, we're talking about months and not years or something like this. Also, when you have to develop something in this environment, we want to check it out. Although this is from the boundary program, this is what you want. But if you're doing your research anyhow and you're using Chauffeur in order to create the workload and measure what you need, and you think, hey, this is actually pretty interesting, and we have not thought about it, then please contact me or us. There's a website at the end of the tutorial and an email. Just contact us, and then we will see how we can bring it into SPEC and evaluate it. And if it's as great, then we will see how and if it's a benchmark or the next tool for server or client efficiency usage, then we will definitely utilize it and credit you accordingly. Okay, at this point, we are at the end of section 2. I hope you got kind of an idea what work has been done in order to put the infrastructure in place so that you can create workloads for this infrastructure. But also, you should have the idea that you do not need all the stuff around it because it's already there. But you only really have to focus on the workload part in order to create it. Max, do we have this Q&A session now, and then having a little break, and then go into section 3?
Sure.
Okay. Is there any other question? Nuba, anything on your side? Arthur, anything on your side? Marius, are you still with us?
Yeah, but I don't have a question at the moment. Thanks.
Okie dokie. Yes, we can share the slides, and we will share the slides. Yes, that is from Ram. A question from Ram. Okie dokie. Shall we have a quick break, and we will add 40 minutes. Shall we meet in some minutes? Does that sound reasonable? 10:40 my time.
So how much minutes is the break?
7.
So okay, all right, thanks.
3 minutes. 3-minute break.
Right. Thanks.
Okay. Otherwise, I will give that to John. Okay, we will meet at 10:40. I don't know what your time is, Max. You're on mute, Max.
Here in Europe, it will be 5 p.m. in 40 minutes.
Okay, 5 minutes. Okay. Okay. Then thank you very much. And let's be switching presenter. And then in the next session, Jeremy Arnold, the developer of the chauffeur harness, will run you to a detailed description how to create your own worklet and beyond. Thank you all so far for staying on, and we will meet in 7 minutes in order to get the third part of our tutorial. Thank you very much. Mr. Jeremy, you can at this point be the presenter. Ram, I'm Klaus. Ram, which company you are with? University.
Yeah, I'm from Microsoft.
Oh, Microsoft, excellent.
Yeah. So I don't know. We are recently, started to look into this power benchmark. So just wanted to have a better understanding. And also, I joined a little bit late to this conversation, so that's why I asked for the slide. But I'll be in the next session to catch up.
Okay. Yeah, the next section is really going to development part, but we have part of our presenter team is and our co-workers is Aaron Cragin. He is with Microsoft, and if you want, I can hook you both up so that you might want to talk with them offline as well.
Oh yeah, sure. What's the name again?
Aaron Cragin.
Okay. All right. Yeah, I noted it down. Thanks a lot.
Yeah, he is primary representative for the SPEC Power Committee and ISG, as Microsoft is heavily involved in the development of our benchmarks.
All right, great, thanks.
And he's also a great guy to work with. I worked with him for the last 15 years, and it's always good.
Okay.
So, Nuba, whom you with? Undergrad student.
Yeah, I'm an undergraduate student in Bachelor of Computer Science.
Are you a little bit? I can barely hear you.
From Brazil, so not from the industry.
I apologize. I cannot hear you. But nonetheless, I hope you can hear us. And yeah, I'm glad to have you over here. And if there's questions, yeah, please put it in the chat, and we will address them at the end of the call. We are there. Max, and Mr. Bao on Huawei. How are you? I cannot hear you. You're on mute, but I cannot hear you. Oh, from Brazil. Okay.
Hello, can you hear me?
Now I can hear you. Hi, how are you doing?
Yeah. Thank you. Yeah, I'm from Huawei, and I have a question for the topic. Because as far as I know, the CNAS, the Chinese National Institution Standard, release BC benchmark tools that is similar with the SPEC search. And I have seen some feedback from the GGG, the Green Grid. As you know, the membership of the Huawei of SPEC membership has been conserved since the 2019. Yeah. So, as a global company, we have no opportunity for our teams to support the Excel tools, and we have to use the new benchmark tools named BC. And I also know there is an alternative CPU bench, which is similar with the SPEC CPU. So my question is, what do you think this situation for the company in China and or for those companies who don't have the right to use the SPEC search or SPEC tools? Yeah, Mr. Klaus-Dieter, this is my question.
That is a complex question, and that is really nothing I can, that is, complex. And with the different governments, they have to agree on that. And that's the work that needs to be followed there. Thanks again for joining us today. I'm glad you'll be able to learn from the third design and what we have done over the 16 years. It is always good to see that because our design documents and what we're describing is openly available, that people can learn from it and taking and seeing what we're doing. And that's a great way to see it. Jeremy, at this point, welcome to the stage again. Thank you very much for making time for your busy schedule for this session. I'm very glad to have you on board. For people who are not familiar with Jeremy, he is a long-time contributor, and he develops fantastic code. And for us, he, in part of his masterpieces, he created the chauffeur WK. Looking back in the days in 2006, Jeremy was involved in creating the SPEC Power SSJ benchmarks, and the items we learned from it. He created this framework we're now using for all of our SPEC energy efficiency benchmarks. And great honor to have you on board. And I'm looking forward to learn a lot of awesome stuff from you today. Thank you.
Thanks, Klaus. So as Klaus has described, SPEC produced the chauffeur WPK based on the information that we learned from developing first the SPEC Power SSJ benchmark and later during the development of CERT. And basically what we realized is that many of the components that were required to develop a quality energy efficiency benchmark were really separate components from the workload itself. And that by developing this framework, it would allow us to plug in different workloads without those workloads really having to develop all those external components. And so the purpose of the Chauffeur WDK, the Worklet Development Kit, was to allow new workloads to be plugged in as easily as possible. This framework was developed in Java, but can make calls to native code, and we do have a couple of examples of that in CERT itself. And one of the key features is really the ability to be able to run workloads at multiple load levels, as Klaus showed earlier. This, in order to leverage this feature, requires transactional workloads, basically a workload that is subdivided into multiple transactions, which is common for a wide set of workloads where there's some user input, and the workload, the transaction then performs some operation on that input and produces some result. And when we're working with transactional workloads of that nature, then Chauffeur can take care of automatically implementing those multiple load levels. Chauffeur does also support non-transactional workloads without that multiple load level feature, but that is appropriate in some cases. And we'll discuss that briefly later in the presentation. So by using the Chauffeur WDK for energy efficiency benchmarks, really allows the workload developer to focus on the aspects that are specific to their workload. The WDK provides the benchmark director, the components that allow us to work with potentially multiple hosts that are all being tested concurrently. It takes care of launching multiple processes on each host and doing CPU affinity to allow those to run efficiently. The WDK includes the report generation, so that we're able to take the output of the benchmark and produce a report that summarizes that information. It includes the hardware discovery features that Mike mentioned earlier to automatically collect some key information about the system, the CPU, the memory, other components, so that the result is accurately described. And of course, the WDK includes the SPEC PT daemon and the interface to that, so that we can automatically collect power and temperature data from a variety of different power analyzers and temperature sensors, and then match that up with the performance data so that we're able to produce meaningful results there. Basically, the Chauffeur WDK is designed to provide a framework that implements the spec power methodology, supporting the multiple load levels, supporting calibration basically to facilitate those multiple load levels, and collecting all the necessary temperature and power measurement data to have an effective energy efficiency benchmark. And so as you look at the diagram or architecture diagram for the total system environment, all of the controller pieces are implemented by the Chauffeur WDK with the support for the power analyzers and temperature sensors, and the general support for handling multiple workloads is all included. And so the goal with the WDK is that you can plug in your workload and benefit from all of the other pieces that SPEC has already implemented. And so as we look at how we would go about implementing a new worklet for Chauffeur, we need to start with a few basic definitions. The worklet, Chauffeur makes a distinction between a workload and a worklet. The workload would be potentially a collection of multiple worklets that are all designed to work together. So they would each worklet would execute on its own, but we would take the scores from those multiple worklets in order to come up with an overall score. And so in search, as we saw earlier, we have separate workloads for exercising CPU and memory and storage. And each of those workloads has multiple worklets that exercise those components in a particular way. Each worklet is primarily composed of a set of transactions, and each of those transactions, as I said earlier, can accept some input, perform some action, some operation on that input, and generate a result. And the concept of the transaction in Chauffeur is very general. We don't care what kind of input gets accepted. We don't care what the action is, and we don't care what the result is. But this model fits a wide variety of workloads. Now, in the context of a benchmark, that the input for that transaction would be something that's typically randomly generated. Of course, in a real application, that input would often be coming through user input, or based on the contents of some file, or some input from some external system. In the context of Chauffeur, the transaction would be responsible for generating randomized input so that the transaction has something to operate on. And we'll take a closer look at that in a moment. Chauffeur also includes the concept of a user, which would represent some user of the system, whether that's a human user or an external application that's feeding into your application. And the primary reason for having that user in the context of Chauffeur is to allow us to maintain some state that's associated with that user. So in many applications, some applications may be completely stateless. In many applications, there may be some amount of state that's associated with the user. And so Chauffeur includes this abstract concept of a user that allows us to include that state information and maintain that over the context of executing multiple transactions. And so each time a transaction is executed in Chauffeur, that user is passed in as one of the parameters to the transaction, and allows us to leverage the state information in that user to influence how the transaction is operated. And so in the next few slides, we're going to walk through the implementation of a sample worklet. We're going to pick a very simple example in order to, for the purposes of an example to walk through quickly here. And so we're going to look at the implementation of a transaction that determines whether a string that's passed in to the transaction is considered a word, basically looking that up in a dictionary and determine whether it's a word or not. Obviously, a very trivial example, and this isn't the sort of thing that we would want to include in a real benchmark. We want to, in a real benchmark or something like the CERT, we want to leverage something more complicated like we would see in real world applications. But for the purposes of this presentation, that gives us a nice concise thing to work with. And so the input of this transaction would be a string, the word or the set of characters to the potential word that we're going to test. And the output from this transaction is going to be a Boolean that's true if the input string is in this dictionary, or false otherwise. And so the first step, and I'm calling this step 0 because this really isn't part of implementing the workload for Chauffeur. This is kind of implementing the business logic itself, and in many cases, and what we hope to see for future workloads that are leveraging Chauffeur and potentially being integrated into a future benchmark or some follow on to the CERT. we'd like as much as possible to be leveraging existing applications or existing business logic. And so, this is largely something that would already exist. And, this is the thing that we're integrating into Chauffeur. And so I don't want to spend a lot of time, if you are a developer, then this code should be pretty straightforward. And if you're not a developer, then I'm not going to teach you how to be one today. So I won't go through this line by line, but basically we're going to start with a dictionary that has some set of words. I'm not claiming that this is an efficient implementation of what we're trying to do here, but a good trivial example. And so our dictionary is going to need to, we're going to need to have a method here, the read dictionary function, which is able to read that list of words out of some file on the file system. And so if we pass in some source to read data from, we're going to read one word per line in that file, and end up with an array of words that are in the dictionary. And so we can create our new dictionary based on that list of words. And then we'll, as part of our business logic, we'll have a isWord function that takes in a string and determines whether or not that it's a word. And in this trivial example, we're going to use a very poor implementation that's going to just do a linear search through the words in the dictionary. And if we see a match, we'll return true. And if we don't see a match, then we'll return false. And it's almost embarrassing to write, as a performance engineer, almost embarrassing to write a chunk of code that is this inefficient for this sort of operation. Obviously, in a real world application, we would use an implementation based on a hash lookup or something more sophisticated to handling the different roots and that sort of thing. But we'll stick with this inefficient implementation for the purposes of our conversation today. And so now we start with step one on actually integrating this basic workload into Chauffeur. And the first thing that we need, as we discussed earlier, is a user. And we're going to, in the context of this application, the state information that our user needs is access to that dictionary that we created earlier. We can imagine that in a real application, we may have users that are working with words in different languages. And so one user might be using a dictionary that has words in US English, and another user in English from Great Britain with some slightly different spellings and things. Other users that may be in using a Mandarin or a German dictionary. And so each user, we need to know what dictionary that they're using. And so that's the state information that we're going to include in our as part of our user. So Chauffeur provides an abstract user base class that handles some of the Chauffeur specific details, knowing what worklet that we're executing, and giving a unique ID for each of the user. But we're going to extend that with information specific for our use case, defining what dictionary that that this user is going to use, and we'll pass it in as a parameter to the constructor. And then we need to provide a method for retrieving that dictionary when we need it. So again, very simple, and the for most of the worklets that are included in Chauffeur today, included in the cert today, really do have very simple user implementations. We do have a couple of examples where they're more complex. The user for the SSJ worklet that is part of the cert is a more complex user order entry application, originally based on the TPCC, and so in that case there is a little more state information associated with each user, and so the implementation is slightly more complex. But even in that case, we're generally leveraging the information that's already part of the workload's business logic. That's and the user from Chauffeur's perspective is really just kind of a wrapper around that in order to make the information available inside of our worklet implementation. Step 2, we need to be able to create those users. In a real application, those users may be created as part of a login operation or something. But in the context of Chauffeur, we need to be able to create users on demand based on how large of a system that we're testing, and how many processors there are often dictates how many users we're going to be running. And so the Chauffeur framework needs to be able to create as many users as we need. And so in this case, the main job of our user factory that's specific for our workload is being able to read in that dictionary. Because multiple users are typically going to share the same dictionary, we don't need to read it from a file for every user. And so we're going to do that once as part of the user factory. And here we've specified where we're going to read the dictionary from, and we're going to in this case just have a single dictionary that's used for all of the users. And so we read in the dictionary, are using that read dictionary method that was part of our business logic from the application that we're integrating, and then Chauffeur defines a create user method that we're going to implement, and that this method needs to know how to create a user based on the information that we had. And as I said earlier, in a more complex implementation of this, different users may have different dictionaries that they're leveraging. That feature is not part of our simple user factory here, but we'll see an example in a moment of making it a little more complex so that is a configurable value. Step 3, now that we have our user and we have a way to create them, is to create the transaction implementation. And this is the part that does the real work that we're going to measure. And so the first thing that we need, as I described earlier, because we're simulating the user input, is we need to have a way to generate that input automatically. And so we define this generate input method. And in this case, we have a random number generator associated with each user. And we're going to define some length of the word that we're going to generate. And so in this case, we've defined a minimum and maximum length that we're going to generate a random series of characters between 4 and 10 characters. And we're going to pick the actual length at random, in this case with a uniform distribution. And then we're going to build up that random series of characters. In this case, we'll limit ourselves to the 26 English letters. Obviously, again, this could be extended to support other languages. And now that we have the ability to generate input data, then we need to actually implement the process method that's going to actually do whatever it is our transaction is going to do. In this case, looking up the word in our dictionary. And in this case, because we're at least in this mental exercise, we're already working with an existing implementation that we created back in step 0. And so the process method is very simple here. All we have to do is call that real business logic from our sample application, which already had a method that does the work for us to check whether this is a word. And this sort of simple implementation of the process method is pretty common across the chauffeur worklets. Sometimes we're implementing the actual business logic in this process method, but as much as possible, we want to again leverage existing logic from existing applications, and so all the process method really needs to do is call into that existing business logic rather than having to re-implement it here. And we have another method that's part of the base chauffeur implementation for a transaction, and that's to provide a way to verify the results. And in this case, and this is a way to check if the as a functional verification that the transaction is working properly. In this case, there wasn't a whole lot that we could do aside from checking if basically re-implementing the business logic in a different way to try and confirm whether this actually was a word, but it would really come down to re-implementing that check to see if it was in the dictionary. But in many other applications, there may be some way that we can verify that the results are correct. For example, if we're doing some numerical calculation as part of our transaction, then there may be some way that we can verify that the result is actually accurate, or at least that it falls within an expected range of tolerance. At runtime, Chauffeur doesn't verify the results of every transaction. It can be configured to do so, but more often we would verify a subset of the transactions. We may just verify maybe the first and last transaction of the measurement interval. We can configure it to verify every 1,000 transactions. There's some flexibility in the configuration there. The reason for not doing it on every single transaction is that we don't want to incorporate extra overhead. For some implementations of the verify results method, this could be an expensive operation, perhaps on the same order or even more expensive than executing the transaction itself. And so we don't want to incur that overhead on every transaction, but it is useful and in some cases may be worth turning this on to verify every transaction. It is something that we can leverage during the development process, of course, to make sure that the implementation is working properly across a variety of systems. And then finally, the last method that we need to implement from the chauffeur's transaction interface is to provide the name of the transaction, and this gets used through the reporter and error messages and things of that nature, so that we can know which transaction we're working with. So the code that we've just walked through is the only Java code that we need for implementing the transaction and implementing the worklet as a whole. We need our user and our transaction. The remaining steps that we need to integrate our transaction into Chauffeur, or integrating our worklet into Chauffeur, is some metadata that Chauffeur can use to know how to invoke the worklet. And for a simple worklet like the one we've talked about today, there's a fair amount of boilerplate in this process that it probably looks more complicated than it needs to be, and perhaps it is. But as we get to some more complex worklets, then this metadata, this worklet definition that we're going to write, gives us a lot of flexibility in how the worklet gets executed. So in the current implementation of Chauffeur, this worklet definition is provided as an XML configuration file. This is something that's built into the worklet. It's we could consider it part of the worklet code. This is going to be what defines the transactions, the parameters, and other characteristics of the worklet. And really, the suggested approach to implementing this definition is to start with the sample worklet that's included in the Chauffeur WDK, copy the worklet definition from there, and then make the updates that are appropriate for your worklet. In order to understand this worklet definition, we need to define a couple more terms. First of all, a scenario is a sequence of transactions. Chauffeur provides a couple different scenario implementations. One is a random batch scenario, and for a worklet that includes multiple transactions, this random batch scenario is going to make a sequence of transactions that each user executes, and that's going to it's going to pick those different transactions at random using a weighted a weighted mix of transactions. And so we might say that there's 50% of the transactions are disk reads and 50% writes, or we might configure it to use 75% read and 25% write. We can define that the ratio of the transactions in that random batch. Chauffeur also provides a sequential batch scenario, and this is for applications where a user would typically follow a sequence of different transactions. You can envision a web application where a user might log in. They may do some browsing through an e-commerce a web store. They may add a couple of items to their cart and then go through a checkout and payment sequence. And so it doesn't make sense in that sort of context to just pick transactions at random. We really want to walk through those different steps. And so Chauffeur's sequential batch scenario would allow us to define that sequence of transactions. There may be still some random elements to it on which items the customer is going to purchase and things, but they're going to follow through this set of steps. The weight, as I described a moment ago, is just gives a relative weight of a scenario or transaction, so we can cause certain scenarios or transactions to be executed more frequently than others. And then Chauffeur also defines a couple of things which are really more benchmark specific. A batch size, which is the number of transactions executed during each scenario. And then the macro transaction size, which are the number of transactions scheduled in a single group. Which that macro transaction size is usually equivalent to the batch size, but not always. We can, if we first look at that batch size, the number of transactions executed during each scenario. Obviously, if we look at that sequential example where the user may be going through a series of steps, that kind of naturally defines a batch that the user is going to log in and do some browsing, do some purchasing, go through the checkout. There's kind of a defined number of transactions that's part of that scenario. If we look at a random batch scenario, we may have multiple transactions that are all part of, logically grouped together. We're picking them randomly, but we still want to define how long a batch is. And in many cases, that batch might just be a single transaction. But when there is some state information that may be carried across multiple transactions, then it may make sense to define a larger batch, which allows us to, that we're going to be operating on the same data for some number of transactions, and then we, throw that away, get some new data that we're going to operate on for the next batch. The macro transaction size is a little more, benchmark specific. As Chauffeur is executing, it's going to be scheduling transactions to execute at different times, and that's how it implements the different load levels that we're going to put delays between each transaction so that we can run at not necessarily 100% usage, but at 25% utilization of the system. We need to insert some delays where the user is not doing anything. And of course, in real applications, the user is going to need some time to think time and things of that nature. And so there's always going to be these delays in an interactive application like that. Depending on the implementation and the nature of your workload, it may be that those, in some cases, those transactions would execute so quickly that the overhead of that that transaction scheduling in Chauffeur would have more, it'd be an unacceptably high amount of overhead. And so in some cases, for very short running transactions, we may want to increase the number of transactions that are scheduled in one group. And so Chauffeur would then schedule that transaction, run perhaps 10 transactions instead of just one, and then schedule the next group to execute later. And so this is an example of just one of the parameters that we have in Chauffeur to make it easy, more adaptable to a different types of worklets that have different characteristics. And one of the things that we do during benchmark development is looking at profile data and things to make sure that what we're measuring is the actual business logic of the application and not just getting a lot of overhead from the framework. And this is one of the tools that we have to make sure that we're being effective in that. And so here's an example of the actual worklet definition in XML for our word is word transaction. And so here we're defining, this we're giving our worklet a name. This is our tutorial worklet. We're telling Chauffeur how to instantiate that user factory that we developed way back at the beginning of this session. And so we just need to provide the class name for that words user factory. The launch customizer is something that Chauffeur uses to help define things like the Java heap sizes for different worklets. Chauffeur includes some fairly generic launch customizers that for many of the CPU worklets that we have in CERT, for example, are able to use a common set of settings that are defined in this CPU launch customizer. Other worklets may have more specific requirements and could potentially implement their own customizer. And the documentation goes into more detail about what sorts of things that you would need to provide if you need to customize how the clients for this workload are launched. Next, we're going to define a set of one or more scenario mixes. In this case, our worklet's going to have just a single scenario mix, and so the weight of this mix is 1. We have a random batch scenario here. The macro transaction size and the batch size are 1 here. Again, we just have a single transaction for our isWord transaction. And so this whole scenario mix factory gets a name, the word scenario mix, and we're defining that that's the default. But we may have worklets that can actually run in some different modes. I mentioned as an example a moment ago that we could have a worklet that's doing driving disk I/O, and perhaps there's a couple different variations that we may be interested in testing. One that has an equal mix of reads and writes, and one that has a more heavily weighted towards the reads, or perhaps one more heavily weighted towards the writes. And so we could define multiple scenario mix factories here that use different weights, a different balance of the transactions, and then we can through the either by setting this default or by overriding the which scenario mix will be used at runtime, we can select between those different variations. And so again, another example of some of the more complex customization that is possible through the framework. But in this case, we'll stick with a simple single scenario, single transaction in that scenario. And so now if we take another step back to look at how Chauffeur operates at runtime, as we have a set of different worklets that we can choose from, there's a configuration file that gets put on the controller machine and then passed down from there from the Chauffeur director down to the individual host in the SUT. And this configuration is going to tell us what we're actually going to do at runtime. It's going to tell us which workloads and worklets we're going to execute. It's going to tell us what different phases, how many intervals we're going to run, how long we run each of those intervals. Klaus showed that in CERT, there's different worklets have different number of load levels, and that's part of what's defined here. This config XML file may also have some worklet parameters to change input parameters for how that define how the worklet's going to run. We're going to have a set of listeners, usually included from a separate file that's going to define what power analyzers were, the PT-daemon instances we have for power analyzers and temperature sensors, and perhaps other listeners as well. We've used examples over the years having listeners that will collect system data for CPU utilization, or making calls out to PDUs to collect additional information that the PDUs might provide. And so there's opportunities for plugging in custom listeners as well as those that are provided by the Chauffeur WK itself. And then we also have a set of client JVM configurations that are defined by this configuration file, again, usually included from a separate file. As Klaus and Nishant mentioned earlier, in the context of the CERT, we have predefined JVM command line options, and the number of client JVMs that will be used for each worklet, and that's part of the CERT platform acceptance process. And so in the context of running CERT, then we're using existing client JVM configurations and just need to reference which one is appropriate for the system that we're running on. For a benchmark or for research purposes where we want to have more control over the client configurations that we're using, then we can override those here and tell it specifically what parameters to use. And so in the context of that config XML file, again, that's something that I'd start with the copy that's shipped as part of the Chauffeur WK, but we then need to add a definition of our worklet to that config file, so that we've already provided a definition of our worklet, but we now need to reference that so that Chauffeur knows to actually run it. And so the main components of our worklet definition is we need to point to that worklet definition XML file that we wrote a couple slides ago. And we need to point to the code, what jar files contain the code for running our worklet. And in this case, we've defined multiple class path entries here, so we can, when we actually distribute our worklet, we'll be distributing that in a jar file. But in my development environment, I may also point to directories that contain the code so that I don't have to do a full build each time I make changes to my class. So that gives you a basic overview of the pieces that we just walked through are all that's strictly necessary to implement a new worklet for Chauffeur and to integrate that into the Chauffeur harness, and then to be able to execute that at runtime. And the Chauffeur WDK does include a couple of sample, includes a sample worklet with some sample transaction implementations, and something that you can refer to as an example. And then, as Klaus said earlier, we'll be providing the slides here as well that includes the sample code that I've walked through. But with that base, I did want to address a couple of other more advanced topics. First of all, how we can make our worklet configurable to support configuration parameters that can be adjusted as part of our runtime configuration without making further code changes. Second, we can briefly talk about non-transactional workloads and how those can be integrated. And then third, for integrating non-Java code into Chauffeur as well. And so starting with making our worklet configurable, there's, as part of our worklet definition file, we can define configurable parameters for our workload or for our worklet. And these configurable parameters can be used to customize the user factory, the transaction factory, other objects that are defined as part of that worklet definition. And so in order to do that, first we need to define an element in our worklet definition XML file. And in this particular example, we're going to add an option for our user factory, that words user factory that we implemented earlier. And we want to make the dictionary configurable. So instead of using this words.dict here, we could point to a different resource that has a different list of words. And so by defining in the worklet definition XML file, if we defined this dictionary as a parameter, then that would get mapped to a set dictionary method in the words user factory. So when we see this definition in our worklet definition file, Chauffeur would call, from the words user factory class, would call a set dictionary method and pass in this string, and then that user factory can do whatever it needs to with that configurable value. And so we would need to modify our definition of the word user factory to implement that set dictionary method. Previously, we were doing a very similar operation as part of the constructor for this words user factory class. We've now moved that into a method so that Chauffeur can pass in the appropriate configurable parameter. Now, that was an example of something that we could now define a parameter as part of our worklet definition file. But in some cases, we want to make parameters that are exposed as part of the runtime configuration in the config.xml. And so first we're going to, so as an example for that, we'll define some new parameters that let us change the length of the words that we're going to work with. We had seen in our code earlier that we had a hard-coded a range of 4 to 10 characters, and we're now going to make that configurable. And so in our config.xml, we're going to need to add a set of parameter definitions and say that there's a minimum word length parameter and a maximum word length parameter. And here we're providing the default values of 4 and 10, that if these value parameters aren't set in the config.xml, then these are the defaults that would be used. And then elsewhere in our worklet definition file, we can refer to these parameters. So when we're setting up our transaction factory for creating the isWord transaction, we're going to, instead of setting a hard-coded value for the minimum and maximum length, we'll pass in, we'll refer to these parameters that we defined earlier, the minimum word length and maximum word length, and we'll just reference those here so that they get passed through. And then with those definitions in place, then when we're setting up our worklet in the config.xml, then we can pass in the actual parameters for these values. And so in this case, at runtime, we're deciding instead of words of 4 to 10 characters, we're going to use 5 to 8 characters instead. And again, some of the samples in the Chauffeur WDK include examples of how to do this. The next topic I want to address is non-transactional worklets. As I said earlier, the ability to run multiple load levels in Chauffeur worklets depends on having relatively short running transactions. And that's what gives us the ability to, again, schedule transactions to happen with a delay in between them, and so that we're not running the system at full utilization. Whereas a more traditional benchmark would usually, as soon as one transaction completes, it's going to move on to the next one. However, when multiple load levels aren't required, Chauffeur does include support for non-transactional worklets. Actually, we do still use that same transaction interface, but we basically define our transaction instead of being something short running. We could just basically define that transaction as running the entire worklet, and so we can put a big loop or whatever in part of that transaction, and do whatever we want there. And then as we're running the transaction, we're going to configure Chauffeur to just execute that transaction one time or a fixed number of times, instead of scheduling it to run multiple times. And we do leverage this in CERT for the flood memory flood transaction, or the flood worklet, because it's a memory bandwidth test that's using nearly all of the available system memory. That can take a relatively long time. You can imagine some of the sets that we run with may have multiple terabytes of memory. It may take a fair amount of time to iterate through all of that, and so we're not going to run that at multiple load levels the same way that we do for some of the other worklets. And so instead we define it to, we're going to run that once or run it a certain number of times as part of our transaction. And so we define the transaction in the same way that we did for the other worklets, except for when we're executing that transaction, it's just going to take a much longer time because we're iterating through all of the available memory. And so, and then in our configuration for the workload, we need to change how it's defined so that instead of running it a set of graduated workloads, we're just going to run for a fixed number of iterations, or we also have a minimum number of iterations that can be used for some to give some additional flexibility that it may run multiple iterations so that we know that we run for long enough. So we set some minimum, but could run longer than that. And then in also in the config.xml, we need to set it to run a no delay series, so that instead of scheduling multiple transactions with delays in between, we're just going to run them one after another if our fixed number of iterations is greater than 1. And then the last more advanced topic that I wanted to briefly mention was how we would go about integrating non-Java code. Chauffeur is written in Java, and that decision was made largely for facilitating cross-platform compatibility. Chauffeur runs on or should be able to run on any platform that supports Java, which is most of them, and the cert supports running on Windows or Linux or AIX, has had past support for Solaris, although that's not currently maintained. In a development environment, we've run on Macs as well, although that's not supported in the cert. So Java was chosen for portability reasons, and the base worklet code, similar to what we've been walking through, does need to be implemented in Java in order to be able to integrate with the framework. But the actual application logic that we're executing as part of the transaction doesn't necessarily need to be implemented in Java, and there's at least a few different strategies for how to go about doing that. One is to use Java technologies like JNI or JNA to make calls from Java down into native code, and that's appropriate for some cases. That's something that we leverage in the cert for our implementation of the storage worklets to do disk IO, because the Java APIs, particularly at the time when cert was originally implemented, didn't give us enough control over the IO in order to ensure that the data was actually getting read and written from disk and not just getting cached in memory. And so we make calls down into native code for that transaction through either JNI or JNA, depending on the platform, so that we have more control over that process. Another strategy for implementing non-Java code would be to have your transaction launch an external process. So instead of executing the worklet directly or executing the transaction directly, we could call an executable on the system, which is going to perhaps an existing application, which is going to do some amount of work, and then once that exits, then our that ends our transaction and we can move on. Typically, that sort of model would be something that would not be kind of that non-transactional model. If we're executing an external process, then in many cases that's going to have more overhead, not appropriate for short-running transactions, but it could be good for launching a longer running application as part of a fixed number of iterations, like we discussed on the previous slide. And finally, another model that could be considered is to make calls such as through a REST API to some external service, which could either be running on the local host or even an entirely separate system. And so in this case, the chauffeur SUT could actually just be a client driver, which is executing or causing code to be executed on a remote server, which could be implemented in whatever language that remote service is implemented in. And I believe we've one of the past papers that the SPEC Power Committee has collaborated on has kind of demonstrated this model of basically using Chauffeur as a client driver to drive a remote system. And with the implementation of the Chauffeur load levels and everything, worked just fine in that environment, even though the client system may not be running at 80% utilization. The CPU utilization on that client system is really irrelevant. It's really the remote system, and because of the way that Chauffeur calibrates how much load the server is capable of and runs at different load levels, percentages of that load, we're able to run at multiple load levels even in that model. And so this can be another effective way of driving activity to other applications, which could be implemented in any programming language. And of course, that doesn't have to be just REST calls. It could be even integrating with theoretically, integrating with legacy COBOL systems running on a mainframe or something should be doable. So that really could be any way of interfacing with an external service. All right. So that concludes our Chauffeur tutorial. Klaus, I believe you were going to wrap up with the methodology, or did you want me covering this as well?
I can do that.
Okay.
Thank you very much, Jeremy, for your very insightful easy way to describe what to do in order to create worklets. And I hope that the audience has now somewhat of an idea how to do it in order to really create worklets, not just for us, but also for the bounty program, but also for but also for yourself. I mean, if you need a workload to create it and really want to not create a benchmark, but just something that runs for you, that is what you have for your own efficiency. Quite frankly, we talk about efficiency here, but Chauffeur itself, if you don't use the power metric in there, is there for performance, so you can create your own performance benchmark there. But of course, here we're looking from an energy perspective at that. And yeah, that makes it easy because the infrastructure is there. All the knowledge we gained or put into the SPEC Power methodology is already included as one in the package. And yeah, you can do your device testing and application testing there. Depends what you want. The short tutorial today should give you a good idea, but quite frankly, tutorials are good, but really when you have it and you use it, that's where the benefit really comes from when I'm doing something. So for the bounty program, what we currently are working on to codify on making it all good and that people get the most of it. If you're already interested, let us know and we can give you some of the details. So the idea is that we're looking and identifying which of the worklets or the stress pattern we would like to see in order to involve or bring into the next benchmark and or in the next rating tool fits for clients or for servers. Also, since we're working right now on the client environment as well, if there's ideas or there's something you want to do that is not on the list, please don't hesitate. If you want to run it and work on it, then we can, and if it's from the quality we want, we definitely can see if we can put it as, not as a boundary program, but then having it as an input for us on where we, of course, providing credit back to the folks who created. If you're one of the SPEC members, you have access already to Chauffeur WK. Otherwise, development kit is available there. And yeah, and then that's kind of what concludes today's part about energy efficiency and how we developing benchmarks, all the input you need in order to create a good benchmark, all the input, the resources you have from the industry itself, just from the software side or the hardware side, in order to create something that is fair across platforms and technologies and software stacks. Again, a lot of these pieces have been already taken care of you, and you can really focus on the workload itself and create something like this. In the slide, you will find our contact information, our websites, where you can look it up. And if there's additional, that would be good in order to contact us, and then we can put you in the right direction if needed, and hook you up so that we can do future development. At this point, I would like to open we have a couple minutes left. At this point, I would like to open the floor for some questions about what is important for you. Did you also some feedback? Was that the right level of information you're looking for? And is there any specific for you, if you would participate in the boundary program, what's important for you? Because we're building it up, we want that people enjoy it, have fun with that. But on the other hand, also get something really productive and that will be later used in a in global government standards. Nuba, I put you on the spot. What did you thought? Is there any information? I know it's a new word for you, but did you get a glimpse on what the possibilities are there? Nuba, you are on mute if you're talking.
Okay. Yeah, it's really interesting, and it looks like I was checking the documentation following the presentation as well. It looks like there's a small, not so small barrier of entry, which is the hardware requirement. So it looks like the tooling that was shown makes it really easy to write workloads. But then you have to, unless you are already affiliated with some institution or research group that already has the tooling, there isn't much you can do. Like, what will be the next step for me as an interested party, which understood the tools? I don't have much to do besides deepening my understanding of the tools via the documentation. But then I have to find some lab which already has these things so I can actually get hands-on.
Yeah. So
yeah.
So I obviously to get doing a full study of energy efficiency and everything, there's definitely some lab requirements there for having a power analyzer. The temperature sensor is required for official CERT or spec power results. But for research purposes, you could go without that. From a chauffeur development standpoint, you certainly don't need any fancy equipment and things. We can run chauffeur without a power analyzer. Obviously, we don't get power usage data in that case, but from development of the worklet itself can certainly be done without that. And to be honest, it was I was probably working on writing the energy the spec power benchmarks and the chauffeur framework probably for 3 or 4 years before I even saw a power analyzer, and even longer before I ever actually ran with one. So you can definitely do a lot of the development and understanding the how to make the workloads run without that without any fancy equipment, and the development kit and things runs just fine on a laptop, and for development purposes. Obviously, as you're studying actual the behavior of actual systems, and that has some requirements for a more controlled environment in order to have accurate data. The other point I would mention, and this could certainly be of interest for research usage in particular. The listeners in Chauffeur are there for being able to collect additional data that's not directly collected by the benchmark, and so as an example, SPEC has implemented the listeners for collecting power and temperature data through calls to ptdaemon, and that's how we get at that data. It is definitely feasible, and I've done this a bit in some internal work. It's definitely feasible to implement those listeners that call and collect power data from other sources, and maybe more, even if you don't have a power analyzer, could be making calls to internal system metrics, counters and things that may already be tracking some of that information, or off to smart PDUs that are tracking that information. SPEC has deemed that those sources of power data aren't consistent or accurate enough to be appropriate for usage in the industry for regulatory programs or official benchmark results and things. But in certain controlled environments for research purposes, that data may be perfectly suitable. A lot of times the concerns that we have with that data is not so much with the for a particular system or family of systems, it may be perfectly appropriate, but there may be some wide variations in how that's implemented across different types of systems and things, and so not appropriate for making comparisons there. But for research purposes, there may be some opportunities for getting that data from other sources that you may have access to already.
Yeah, that's exciting and pretty interesting. I think the idea is getting your feet wet on this. Like, once you get the understanding of the tools, if you can find a way to start collecting some type of data that can help you build your intuition and your understanding of the area, then you can later move on to precise instrumentation. And also, please consider, this is my first contact, as I said, and some things in my viewpoint may be quite naive. So I apologize if the question doesn't make a lot of sense for those who are already familiar with that.
No, it's perfectly fine. That's awesome, and it's awesome having you on board here. So that's definitely good. Marius, is there anything on your end? Anything, last questions before we conclude?
No, I'm fine, but I think someone's raising their hand.
I think Bram, you had some questions.
Yeah, I have a question. So basically, I wanted to understand. Are you able to hear me?
Yes, yeah.
Yeah, I want to understand from the code perspective, which part of the code runs on the controller and which part runs on the agent or the system under test, and how does it ensure the infrastructure code is not contributing towards any skew in the power measurement?
Yeah, good question. So, and that's always certainly a risk and something to pay attention to. All of the code that we wrote in our during our tutorial here that's specific to the worklet really is something that runs on the system under test. As much of the chauffeur harnesses as possible is things that run on the system, excuse me, the controller system. So all of the reporting and the interface to the SPEC PT daemon for collecting the power data, all of that sort of thing does run on the controller system. So it has as little or no impact on the system under test. But obviously there is some components of the harness that do need to run on the system under test itself in terms of scheduling workloads, scheduling transactions to run at a particular time. The input generation, is not included in the response time that we report, but it does use some system resources, and so it can impact your throughput. And so those are some factors that you need to be aware of as part of the workload development. And that input generation piece in particular, I think we've run across a couple of examples in the past where the naive implementation could be spending as much time generating random data and things in the generated input as it does actually operating on that data. And so as part of our work in the SPEC Power committee, we've do some profiling things to understand how the worklet is actually executing on our systems, and if we and as a even as a simple first step, just looking at some of the metrics that are produced by Chauffeur to understand how much time is spent generating input data versus the transaction execution. And if we see that that's too high, then we need to explore some other opportunities for how to generate that random input data more efficiently. And so, for example, in some of the CERT worklets, we may have instead of generating completely random data for each transaction, we may have a kind of ahead of in advance of the actual workload execution, generate a set of random data to work with, and then on each transaction, instead of getting a full set, we may just point to a section of that data or do a relatively cheap shuffle, so that we're maintaining that randomness so that the system is behaving in a more realistic manner, but without spending a lot of time on that input generation. Just as one example, but yeah, it's definitely something that we keep an eye on. We want to try and keep the overhead on the SUT as minimal as possible. I guess the last point that I'd make on that topic is that we also understand that real applications are going to have on real world environments are also going to have some level of infrastructure that's involved for managing the application, and so getting down to zero overhead is both not possible, and it in some sense it's realistic to have some of that overhead that really is going to be seen in real applications as well. So it's okay if it's using a little bit of time. We just want to make sure that what we're measuring is really dominated by the actual business logic.
All right, thanks a lot.
Thanks for the question.
Yeah, awesome question. Yeah, very nice. Okay, at this point we would like to conclude. I promised that we had prize to give away. I won a copy of our book System Benchmarking for the most interaction, and we decided that Nova, you are the winner of that book. I think that will give you a nice start into your way to look into performance engineering and get a good head start of what's going on in this world. Congratulations.
Wow.
Yeah, if you just this email, send me where I was supposed to send the book somewhere in Brazil, and then we will get it to you. Okie dokie.
I keep my copy within arm's reach too, so.
Excellent. Okay, thank you very much for joining us. Also for all the co-authors and co-presenters. Always there's a lot of work in order to prepare something like this. I'm very fortunate to work with all of you together on this. I'm very happy about that, and great to see what kind of progress we made. But then from the side from the awesome questions we got here, I'm really happy with that we had this interaction, and I'm looking forward for an awesome workload development in the future. Thank you very much, and we conclude our call. Thank you. Bye-bye.
Thanks.
Thank you.
Max, if you want to have a moment.
Sure.
Okie dokie. That was it. I think we did a good job. You guys did awesome.
Do we want to stop the recording?
We should, if you can. I think